Hi, this is Ken Kane with Lighting Services Inc. I'm here today to talk to you about the new optics that we've developed exclusively for our LED module-based lighting fixtures. Specifically, we've developed a new M40 lens and a new M20 lens. The reason that I wanted to talk to you today is to try to differentiate between what you may be seeing typically in optics with module-based fixtures versus what you'll see with the optics of the LSI fixtures. So what I want to do and demonstrate on the wall behind me is to show the difference between beam angle and field angle, and how typically with an LED module you usually get a fairly large field angle. And so one of the things that we've done with our new optics is to try and reduce that field angle and give you a really good usable beam angle. But in order to do that, I just want to show you the difference between beam angle and field angle and kind of walk through why you get a very wide field angle typically with an LED module. Okay, so the beam angle by definition is measured from the center beam, which is the highest point, the most intense point, out to 50%. And so if I take my light meter and I take a look somewhere close to 800 foot candles, when I bring that out to where it reaches 400 foot candles, that's the edge of my beam. So here I can see I've got a beam that's about 1 foot round. Now, what you get for a field angle though is measured out technically to 10%. So what that means is I've got to go from my center beam, which is around 800 foot candles, out to 10% of that, which is about 80 foot candles. And as you can see, I've got to come all the way out here to reach 80 foot candles. So you've got a very large field angle compared to a relatively small beam angle. So now let's take a look at the same exact module, but fitted with one of LSI's new M20 optics. And the whole reason that we developed the optic the way that we did was to really get rid of that secondary field and reduce it so that your beam angle is a true beam angle and you can control the light much better. So taking a look at the beam that we have up on the wall, it's still a 20-degree beam, same intensity in the center beam candle power is the same, but what you've got is when you move it out to 50%, which is then roughly around 400 foot candles out at this edge, you've got the edge of your defined beam. But then if you go out to 10%, which is where the field angle ends, it'll be around 80, you're very close to the actual beam angle. So the difference between the beam angle and the field angle on this new optic, the proprietary LSI optic, is much closer compared to the previous optic that we took a look at, where your beam angle and your field angle are very much different. So even though I'm in a little bit of silhouette here in front of these two beams, I just wanted to explain a little bit about the difference between center beam candle power and total lumens of a fixture. So as I explained before, the difference between these two beams is in the definition of the beam spread and the field angle. Okay, the beam angle and the field angle. So as you can see over here, we've got a very tight beam angle. The field angle and the beam angle are actually very close. And even though the center beam candle power is the same for this fixture as it is for this fixture, you've got a much larger field angle. So what that translates to is you've got a lot more light in the field and beyond that, which adds up to a higher level of lumens coming out of this fixture than you have coming out of this fixture, even though you've got the same, relatively the same center beam candle power or intensity at the center of the beam. And one of the things that you should always do when you're looking at things like IES files and trying to figure out calculations for a space, the best thing to do is really to mock it up and to take a look at it to see what you're actually getting in the space. For more information on these optics and any of our other products, please visit us at www.lightingservicesinc.com. Thank you.